When human lungs encounter the thick smoke of a structural fire or an industrial chemical spill, it creates what safety experts call an IDLH environment, immediately dangerous to life or health. In these spaces, physiological failure happens in seconds. To operate in these zones, emergency responders have to carry their own breathable atmosphere. A self-contained breathing apparatus, or SCBA, provides a portable supply of clean, compressed air that acts as the single physical barrier between the user and a toxic environment. Before engineered solutions existed, early firefighters relied on crude physical filters, sometimes growing out long beards, dipping them in water, and biting down on the wet hair in an attempt to block incoming smoke. By 1823, Charles and John Dean built a more rigorous physical barrier. They designed a copper smoke helmet fed by a long leather hose connected to a double bellows pump outside the hazard zone. That basic architecture, a sealed, air-supplied enclosure over the head, provided the template to conquer another unbreathable environment, evolving into heavy surface-supplied helmets for deep-sea divers. By 1945, the Scott Air Pack introduced the modern configuration for emergency response. Instead of dragging a vulnerable air hose connected to a distant pump, users carried high-pressure air in a backpack-mounted cylinder. In less than a century, surviving a toxic atmosphere transitioned from desperate, improvised filtering to precision, self-contained engineering. Today, all modern SCBA units are divided by one critical mechanical distinction: how they handle the air you exhale. This schematic outlines an open-circuit system. Air leaves the cylinder, passes a regulator, and exhausts entirely outward. A closed-circuit rebreather traps exhaled breath, forcing it through a potassium superoxide scrubber, which reacts with moisture to remove carbon dioxide and generate breathable oxygen. Because open-circuit cylinders deplete their finite air supply in roughly 30 to 60 minutes, closed-circuit systems are explicitly mandated for mine rescues or long tunnels, where extraction teams require up to 4 hours of continuous operation. Matching the exact circuit design to the threat's duration is the first required risk mitigation decision before a responder ever crosses into the hot zone. Once the gear is selected, the physical donning process follows a strict sequence. Operators must secure the waist strap before addressing the upper body, anchoring the heavy cylinder's weight firmly onto the hips. Next, they pull the shoulder straps tight while performing a short vertical jump. This single motion forces the cylinder's center of gravity to drop and lock flush against the back. Before breathing from the tank, the system undergoes a mandatory leak test. The user fully opens the cylinder valve, then shuts it tight. If the needle on the pressure gauge drops, it means air is escaping. It must remain completely still. The most vulnerable point in the entire loop is the facepiece. If the rubber seal does not map perfectly to the user's face, any sudden drop in internal pressure will pull the surrounding toxic gases directly into the mask. To prevent users from unknowingly draining their tanks, units are equipped with a mechanical failsafe. An alarm or physical vibration, called a vibralert, triggers the moment the cylinder pressure hits a 50-bar threshold, signaling imminent depletion. The finest hardware fails if worn improperly. Surviving a hazardous atmosphere relies on the flawless execution of these pre-entry mechanical checks. Operating under air places a severe physiological toll on the body. The heavy harness restricts thoracic motion, the full-face mask limits peripheral vision, and the physical act of pulling air through a demand regulator elevates heart rates and oxygen consumption. To minimize these physical handicaps, strict, individualized fit testing is a non-negotiable requirement. This ensures the precise size and geometry of the mask matches the specific contours of the operator's face. Beyond individual fit, the hardware is governed by stringent regulatory frameworks. Firefighting gear must comply with the National Fire Protection Association's 1981 standard, while industrial units follow NIOSH's 42 CFR 84 regulations. Maintaining that compliance requires flawless documentation. Composite air cylinders, for instance, must pass hydrostatic pressure testing every 5 years and be retired permanently after 15, with every inspection date perfectly locked. Routine quality assurance audits verify these exact maintenance records, proving that the equipment sitting on the rack is structurally sound and ready for immediate deployment. An SCBA operates as an interconnected lifeline. The mechanical integrity of the pack requires a trained operator to wear it correctly and an active institution to document its maintenance. Review your facility's safety logs today, audit the compliance documentation for every breathing apparatus on site, and verify that every emergency responder has completed up-to-date, certified training.